Atik,
Good evening, sir.
yeah, good evening, Pranav. How are you?
Fine, sir.
Oh, great. Yeah, uh, we're gonna start today a new lesson.
Yes, sir.
Should actually right. Uh, Let me right. Uh,
Sir.
yeah, today basic idea to for this today class is to understand actually motion of the bodies and what are the laws we have to understand the motion of our bodies. So this
Yes,
is
sir.
one of the Pranav, are you there?
Yes, sir. Yes, sir.
Yeah, very important. The famous scientist who was actually who explained the laws of motion. The laws of motion play a very important role in physics to understand the concepts of laws motion of the bodies. Without laws of motion, I wouldn't even I wouldn't understand anything about physics. So definitely these laws helps a lot to understand the physics. Okay. All right. uh, so when I say laws of motion, you can understand actually laws of motion. Why I'm saying laws of motion? For any object, when the object is in motion, there are laws are proposed by the scientists. The famous scientist, the famous scientist. I guess you understand who is the scientist who described the laws of motion. Do you understand? Do you know that? Pranav, who is that?
Newton, sir.
Yes, great. So Newton is the famous scientist who was actually dreaming about the physics, who was about the gravity always pulls the object toward the center of the earth, is the one Newton. Okay, so without Newton we can't
Yes, sir.
imagine gravity. So with the gravity all the objects pull towards the earth, center of the earth. So with Newtons, we learn a lot of things. As you can see here, the ball is spinning. I mean, the ball is in motion. Simply, I would understand what is this. It's just motion, spinning a ball. What is it would be? What kind of motion I would say? I mean, what laws actually? I mean, how do you describe this object? What I
Yes.
need to understand this motion? I want to discuss about it, but what? How can I discuss it? So there are a lot of questions comes out. So with our brain, first when you look at this, what are this? Yeah, it's ball. Next, what is this? What is doing? It's spinning. Then how can I understand this motion? Laws of motion, maybe motion equations of motion. How do you apply that? Because equation of motion they don't involve the force, right? Without force, I mean to spin a ball, what do you need? Tell me. To spin a ball, to spin a fan, definitely what we need? What do we need?
Oh, energy.
Yeah? What do you need? Tell me.
Energy, sir.
Before the. Okay. Satvik? Satvik, ask him to come here. Give me one. Hold on, hold on.
Yes, sir.
Satvik? Yeah, right. Uh, right. Satvik here, come here. Give me 1 second. Satvik, are you there? Come here. Give me 1 second. Yes, yes, let me. Right, guys, I think, yeah. What is going on here? Pranav, what do you need? The ball is spinning, right?
Rolling. Yes, sir.
Yeah, ball is spinning. What it required to spin the ball?
Force.
Oh, yes, correct. Force definitely require a force run the to spin the ball, right? So how do I understand this spinning of the ball? What I need? What are the parameter I need to understand this ball? To understand the motion of the ball?
Yes, sir.
It's spinning in one direction. Or does it spinning and moving in one direction?
Yes, sir.
I would definitely think about. Here I can see that. Oh, give me 1 second, madam. I'm in the webinar, madam. Hello, I'm in a meeting, amma. Right. Yes. Yeah. The ball is moving in this direction. I would say the ball is moving in one other direction. So how to move the ball in one direction? Yeah, the two things you have to understand, guys. Ball is spinning and it's moving in one direction, right? So, so to spin a ball, to spin ball and move in one direction, what do you need? Definitely, we need a force. Then what else do we need? Tell me, guys.
Friction.
Friction? Who said friction? What is your name?
Spurti.
Spurti. Hi, Spurti.
Hello.
Why we need friction here to understand the spin and motion of the spin of the ball? What do you need? Why we? I mean,
Uh,
friction doesn't play.
oh, friction will stop the motion. Yes, yes, yes.
But let us say I ignore the friction. So let
Then
us
the
see
ball.
the friction doesn't play anything here. See, do you guys? There is a one more quantity code. There is a one more physical parameter. Is called torque. R cross F, right? Do you guys know this?
Mm.
Let me clear it. Let me play again. To spin any object, what we need? You said you said force, right?
Force.
Then what else do we need? I mean, does it? If I apply force, does any object spin immediately? No, right?
No, sir.
I mean, if I pull you guys, do you spin it? No, right?
No, sir.
What we need to do? We need to do something. Yes, what we need to do? We need to fix the axis first, right? The
Yes, sir.
the object should rotate around a fixed axis, right? So for that purpose, we apply the force. We apply the force initially and continuously, basically. I mean, in case of spinning ball is different. In case of fan is different. In case of fan, what we do, we fix the axis with a radius of r. It rotate around that radius. That's a the spinning of fan in a fixed axis. It doesn't move one direction. It doesn't move any other direction. It just rotate there itself. But here the ball is spinning and moving in a one direction. So here two types of motions are going on. One is linear motion. The other one is rotatory motion. Right? The two motions are going on. One is rotatory motion. The other one is linear motion.
Translate.
Translatory. Very good. Translatory. What we need? We just need a force, right? For
Yes,
Yes.
sir.
translatory motion, we need only force.
Force.
But spinning, what you need? Force and something else. So we radius also we have to R cross F. That is called torque, turning effect of force. Turning effect, which means to turn every second, we need to find R cross F. We need to apply a kind of torque. Torque is a turning effect. To turn, to rotate any object, you definitely need R cross F, which means R cross F. Just like uh, if you know that, let R cross F is a force is
Excuse
torque
me.
is around z axis, R and F are the x and y axis. R cross F, x cross y can give the z axis. So here with R cross F only, the object can spin. But when you apply force, it also, the object can also have the translational motion. So here, the first point I think we understand, without force, we cannot move the object. We cannot even spin the object, right?
Yes, sir.
Without force, we cannot spin the object. We cannot move the object from point A to point B. I mean, displacement, in order to have the displacement for our object, you need to apply the force, right? So I'm not going to explain which law, first law, second law, third law. I don't explain. First I'll explain, then I will come back what is action. What is going on here? Tell me.
A car is sliding down.
Yeah, then what is going on? I mean, yes, I know that. Yes, cart is sliding down.
Rolling with translation. First, the car will roll,
Uh,
and after completing the steep line,
uh.
and then it will translate. So, rolling and translation both will take place in the
Yeah,
situation.
but there is a kind of phenomenon is going on. There is a inertia, right? Inertia.
Yes.
Inertia. What is inertia?
Hmm. Rolling.
Inertia should know, guys. Inertia. What is inertia?
It's a measure of mass.
It's a measure of mass. Then, how do you tell physics? What is the physics behind it? Inertia. If I have a more inertia, what should I do? If I have a less inertia, what should I do? What is the actual? Can you explain? Can you interpret it? What is that?
Hmm. Yeah.
What is inertia? What it does actually, at least, which always what?
Uh,
Pranav,
Sir.
can you describe it? What is inertia? Inertia means does it oppose something? What it oppose? Suppose you are standing in the bus. Okay, you are standing in the bus. The bus is at rest position. Suddenly, driver started the bus. What happened? Tell me. You are standing in the bus. Bus was actually at rest position. It was on the bus stop. Let's say you enter into the bus and there was no seats there. You are just standing. Suddenly you are thinking about some, like you are thinking, you are dreaming about something. You are getting ideas something. Suddenly driver started the bus. What happened? Tell me. What you can you imagine? What happened?
We will fell forward.
Why? Why you fell in forward?
Uh, because sudden break.
No, no, that not like should physics. We want to discuss physics.
Friction. It opposes force.
It
Opposes force.
it opposes the motion. That's correct. But what is going on there? When I immediately started the bus, so I must let us say I'm driver. I'm driving. Suddenly I just started the bus. You guys are standing in the bus. What is going on? Like when I start the bus, what is your status? You are in somewhere, you are not looking me. You are standing in the bus. I started the bus. So the bus already go, the bus gets a motion. But how about you? You are in the rest, right? Uh, the bus got a
Yes.
motion, but what about you? Your entire body was in rest position, but your legs get a motion. So legs are pulling towards the forward direction, right? Your body is still in rest position. The body didn't get any motion. The body. So where you can do you go?
Sir,
uh,
just 1 minute, sir. 1 minute, sir. I'll just come, sir. Just
Do
1 minute.
you fall forward direction, backward direction? Tell me now.
Backward.
Yeah, but you said before what? What you said?
Forward.
Oh, I see. You are not asking your brain to think. Don't tell direct answer. You should always think. Oh, physics is there. Very nice physics is there. You just need to think. So the another example that I want to bring you, yeah, similar example. So we are all in the bus. Okay, we are the bus. We are all in the bus. The bus is in the uniform acceleration. Let us say uniform motion. Suddenly we were, standing. All of we are standing there in the bus. Suddenly the driver, someone crossing the road. Suddenly the drivers, stop the bus, brake. He just apply the brakes. So what happened for us? Can you describe anyone?
When he suddenly applies brake, the legs will move.
The driver suddenly apply the brakes. So bus almost
Yes,
right.
sir.
So what happened? Can you describe? Anyone can describe?
Mm,
Rathik?
When
Easy. I already explained one case. You have to explain another case.
the rail suddenly applies the brake,
Or
our
at least which direction you
our
fall.
legs
We
will
fall.
move
Huh?
backward so that will our legs when the driver suddenly applies brake,
Huh.
so our legs will be in the contact, so they will move backward.
Oh, our legs immediately. So
Uh, Move.
they don't move, right? See, when bus
No,
stops,
no,
legs
relative
do the leg
motion.
move? They don't move, right?
No, just
So
a jerk.
you immediately stop. You see, simple example. You are going in the car. You suddenly stop the car. What happened? We move forward direction, right? Why? Because our legs, basically our legs are contact, the legs and surface of the car, the legs and the surface of the bus,
Are in
there is
contact.
a contact, right, between them. So when bus stops, legs immediately stop, the motion of legs immediately stop, but the body doesn't know up to that point. The body is still in the motion. So the body move forward direction. The legs already stop for motion. The motion of legs, the bus surface already in the rest position. So in that case, you fall in the forward direction. The legs still there. The legs they do not move. Your body only moving, right? So what kind
Ah,
of this phenomenon is called? Inertia, right? Is it inertia? Change in motion. The inertia which always oppose the motion. Inertia definitely we describe in terms of mass, because if the mass is more, we can see something else. See, we cannot compare, like, me and you, it's completely different. My mass is more than your mass, right? My inertia is different than your inertia, right? If I keep a lorry and car, definitely if lorry come and bump the if lorry comes and bump the car, what happened? Which one damage more?
car.
Car. So definitely moment of inertia is completely depends on the mass, and so which always oppose the motion of the bodies. That's what you have to understand. Okay. So here actually in the
Mm.
motion, the cart is, you see, initially it was a rest because of this the surface is slope, inclined surface, so it get a motion. But once it, it become a after some, like when it reaches the plane surface, suddenly it stops. I mean, not suddenly, its velocity becomes zero. So my question is, if I want to describe this situation in terms of the laws of motion, I mean Newton's, what he was describing about this. So Newton was actually, he proposed the first law, stated that the object is in motion or a rest until and unless you apply the force, right? If you don't apply the force, the object is in rest position, right? Or uniform motion. Once you apply the force, what happened? It gets motion, right?
Yes, sir.
So, in the absence of force, the body should not move, or if it moves, it should be uniform motion. Is it clear? Suppose if I don't apply the force, the object should be at rest or uniform motion. But when I apply the force, what it gets? It gets acceleration. Definitely, it's not anymore uniform motion. Its motion changes. Is it clear? I hope you understand,
Yes, sir.
guys. Now, what is going on this guy? What is doing this guy? He's applying Satvik. Yes, you're right. He's applying force. Then what is going on? When you apply force, what happened? So when you
When we
apply
apply
force, there is a change in
change in,
acceleration. There is a change in acceleration too, right?
yes,
So is see what is doing? Like, apply force must be equal to product of mass and
yes,
acceleration. So this is like a second law. So rate of change of momentum. What is the definition of second law? When you apply the force, the object can get, the object actually, what it undergoes, it undergoes change in momentum. It undergoes change in momentum. So when I apply a force, the object actually undergo change in momentum, which means what? The momentum of the object changes. Momentum of the object can change. Let us say t. So here you can also write this as, if you take common m, v minus u by t. So this is equal to ma, right? Is it clear?
Yes, sir.
So F is equal to ma. If someone asks you to get it, what do you do? First, you need to write, remember the force definition. Someone asks you what is the force? It's nothing but rate of change of rate of change of what? Tell me.
Acceleration.
Momentum, right?
Oh, momentum.
Rate of change of momentum is called force. So you can, some other student can say it's a product of mass and acceleration. This is also correct. But in general, you have to remember this one. So F equal to ma came from this actually. So F is defined as rate of change of momentum. That is equals to mv, final momentum, minus initial momentum, p2 minus p1. So that if you take m common, v minus u by t, from equation of motion v is equal to u plus at, what we got, a is equal to v minus u by t. So that becomes ma. Okay, is it clear? So now we understand second law is compulsory, it's related to the force. Okay, whenever there is a force, there is a change in momentum. Is it clear? Can I erase it? Can I clear it?
Yes, sir.
Right. So when I apply the force, there would be a change in what? Momentum, right? When I apply a force, there would be a change in momentum. There would be change in momentum with respect to time t.
Yes, sir.
So now there is a great, the third law you can see here. So what is going on here? Tell me. There is a bump. You can observe the surface first. There's something is going on there. Action and reaction. Action and reaction. What are these? Does anyone knows that?
Yes.
Tell me, what is this action and reaction?
Every action is equally action.
Every action, very good. Every action there is a equal and opposite
Opposite
reaction is there.
reaction.
So what is the physics we have to understand there? Every action there is a equal and opposite reaction. So I would understand here ball is bumping back. Why it's bumping back? Because of surface is also applying force. When the ball touches the surface, the surface also equal amount of force apply on the ball. So action is the first one when ball applies a force on the surface. Reaction is the surface apply equal amount of force on the ball. So action, reaction, forces are equal and opposite direction. And there is one more thing that we have to remember it. They do not act on same surface. Is it clear? Sir, I didn't understand. They do not act on the same surface. What is the meaning of same surface? Here there are two surfaces are there. One is the ball, the other one is the ground, whatever surface that you are hitting the ball, like a wall, whatever. So ball is applying a force on the surface of wall, but wall is applying the force on the ball. So they are applying each other, but the forces are not, action reaction force are not applying a single surface. They do not apply a force on a single surface. Okay. If they apply
Yes,
a
sir.
single surface, what happened? It doesn't move, it doesn't bounce back. Right?
Yes, sir. Yes, sir. Yes, sir.
Action, reaction force are the equal forces and act opposite direction, and they do not act in the same surface. That's what you have to remember. And the principle behind the rocket also same thing. Rocket, why rocket is going like, launching, like what is going on there? Simply same principle. So it pushes back and it goes there. So the forces should be there also. Action reaction force should be same. But after that, does it come back? No, because once it go up, then they give the energy to reach the satellite, certain orbits where it rotate around that, in that orbit only. It doesn't come back. Once it reaches the orbits, it doesn't come back. It rotate that particular orbit only and give the information about whatever you are looking. Okay, now yes, few more things that we have to discuss here. And you can see here the two guys are doing something here. What they are doing? So to move a football which is at rest, initially football is at rest. So
Yes, sir.
once you kick it, what happened? It gets motion, right?
Yes, sir.
So here, so external force is important. External force is needed to retard or stop the motion. When you kick the ball, how do we stop it? You have to apply some force, right? Even to kick the ball or to stop the ball, what we need? What do we need?
Four.
Force. To kick the ball or to stop the ball. Definitely, we need to apply the force. Okay?
Yes, sir.
So, force, if I ask, what is the force? Sir, force is a pull or push which generate or tends to generate a motion in a body at rest, or stops or tends to stop a body in a motion, or tends to change the shape of the body. So many definitions you can give. Sir, you said just now only it's a change of momentum, sir. Yes, of course, it's a force is a change of momentum with respect to time. But this is what going on here actually. So force is a pull or push which generates the or tends to motion when a body at rest. So body at rest, but when you apply a push or pull means you are pulling it object, push means you are pushing the object. Okay. So definitely we are applying the force. Even if we pull or push or stop or move the object, definitely we need some physical quantity which we call it as a force. Simple definition, generalized definition, that is not like a, so I mean, someone asks, if suppose if I ask a village person, sir, what is a force? Force is just pull or push, sir. What is pull and push? Yes, that's also correct. The force is a which stop the motion of the body, sir. Yes, that's also correct. Sir, the force is a which helps to get a motion of the object. That's also correct. All these events definitely related to the force only. If you want exact definition, it's a rate of change of momentum is called force. All this related to the force definition. Okay,
Yes, sir.
is it clear?
Yes, sir.
So what are the external forces and what are the internal forces? What is actually internal and external? Let me, anybody knows what are the external force and what are the internal force? Does internal force move, help the object to move? Does internal force help to move the object, or external force to move the object? Yes. So external force helps the object to move. Why not internal? What happened? What is internal actually? What is internal force? Suppose you are sitting in the car. You are applying lot of force on the seats and to move the car. Does it move?
No.
Yes. No, no, I think.
Yes. You are sitting in the
No.
car. I ask you to move the car. You people are sitting in the car. I ask you to move the car. You are applying force. One person is applying on the seat. One person is applying the force on the gears. Like you are applying everywhere. Doors, windows, everywhere. Does car moves?
No.
Yes or no?
No.
No. It doesn't move. Whatever you fight there inside, you push, you pull, like whatever you do, it doesn't move. So internal force does not help to move the object. But when you come out, when I ask you to come out and push the car, definitely it helps to move the object. So if on the the force applied on the any object inside, if a force applying agent inside system, which is actually internal body, like internal force means, suppose you have all the gas molecules, etc. There is interaction between the molecules, which is called internal forces. Suppose you guys are sitting in the car, you whatever you do, the forces, we call it as internal forces. So it does not provide the motion of the system. So whatever the internal forces are, they do not cause for the motion. Okay. So when you apply, even you can take that gas cylinder is there. So gas cylinder inside, what is there? Molecules are there, right? What is there inside the gas cylinder? There are some molecules are there, right?
Yes, sir.
So when I keep the gas cylinder and a fire, what happens? When I
Will
apply the heat under the gas, I put a gas cylinder on on the stove. What happened? Tell me.
the gas cylinder will be burst
Why?
because external force is applied and the moment.
Yes. When you apply the external force, that is actually heat is the external force we are applying. When you apply the external force, what happened? Internal, whatever the molecules are there, internal, the interaction become
the
more and more,
yeah,
right?
the energy
Yes, sir.
will increase.
Yeah. When the interactions are more and more, what happened? They don't no more, they don't they don't want to inside, they get more energy, they got more energy. Once you get more energy, what do? You jump out of it, right? So
Yes, sir.
if you don't eat, if I ask you to jump out of the gate from your house, you can't jump, right? But when you eat, suppose when you eat, you have when you have energy, if I ask you to jump out of the gate from your home, you can jump, right? Suppose you got a fever, you didn't eat anything, you are sitting at home completely 2 days. If I ask you to jump without opening the gate, sir, please, I can't even walk. But when you have energy, suddenly you can jump easily, right? Same thing here. So the gas molecule got a more energy. They don't want to sit anymore. They want to come out of it. It just blasts. So that's a very simple physics going on. So from there, yeah, that's what I think. I already explained this. If you are sitting in a car and you push it, it doesn't move. If you come out and push it, it just moves, right? So internal push does not move the car. External push, it helps the to move the car. What is the force here? Question number one is force. Maybe if they ask question like what is the force? It is a pull push which tends to move the body. The second B option is stop, tends to stop the body in a motion, tends to change the shape of the body. All the above. It seems like all correct, right?
Yes, sir.
So the next, yeah, as I mentioned already, it's the first law of motion, also called law of inertia. So first law, this is the first law. The first law always describe the motion of the, I mean, law of inertia. So inertia is what? What is inertia? As I mentioned already, it's a property of a body which always oppose the motion. If the external force is zero, the body remain at constant, right? It doesn't move. If the net
Yes, sir.
external force is zero, the body still continue in uniform motion or at rest. But when I apply force, it moves. So basically, definition of the first law of motion, if someone asks you, so you should remember that, very important. You have to remember this statement till you till your life ends. So don't
Yes, sir.
forget it. So to understand the first law of, because the great scientists proposed that, right? Should not able to forget it. If net external force is zero, the body at rest continue to remain at rest, or the
Or the
body
body.
motion, uniform motion. This property, this is called first law of motion. This is also called inertia, law of inertia. And this property of the object is called inertia. Inertia is basically related to the motion of the body, which whether it is rest or motion, which always want to sit actually, which always want to at rest, which always oppose the motion. It doesn't. So like a sticky, this guy always sit. He doesn't even get out of it. He always want to sit in a home. He doesn't want to come out and play with others. The inertia is more this guy. So he has a more inertia than other guys. So sitting at home always 24 hours is inertia, right? So inertia, more inertia related to the kind of like, uh, it's related to the, again, um uh, like it's not so excited to see the world. The person who want to explore himself in all fields, the person who want to come out of the system, enjoys his, do other things. So inertia is less, he can do anything. If has a more inertia, is like a dull person, like he doesn't want to explore anything. He just always sit at home. He doesn't want to explore. He doesn't want to share his ideas to anyone. Okay, so
Yes,
inertia is
yes,
kind of stuff that you to understand more. Okay, inertia means resistance to change. You can think about here also. Inertia means resistance to change. Like he's sitting like that. I'm pushing it. Go, man. Go out of. Come out of. Like that. A ball at rest, stayed at rest, unless you acted upon by force. So resistance to change. Okay, like a very what happened. Okay. So basically, I think we don't have much time now. We have 1 minute. Maybe disconnect soon. You can connect back with the same ID.
okay, sir.
Yeah, inertia is nothing but resistance to change. So which always oppose the motion. Okay. So the physicists, the scientists have a special name for this inertia. Laziness. Yeah, I was trying to bring that word. Lazy person. It doesn't, is not active in the class. So inertia is nothing but laziness. So this is what word we use for the inertia. So laziness. Okay. If things are at rest, they want to stay in the rest. If things are motion, they want to be in motion. So that is what first law. Remember that. So if it should be at rest, it should be a motion, but without involving the force. Okay? So there is no
Yes, sir.
force involvement here. Every body continues its state of rest or its state of motion until and unless external force is applied. You have to remember this definition. Every body, everybody, every body, every object